if you see enough reaction diagrams, you realize that you will see just two types of reaction diagrams. We have the type that look like, hold on, here we go. Now we have on the left side, release of energy, and on the right side, absorb energy. All right, start with on the left side. So the left side right here, so the energy of the reactant is higher than the product. Right, so we call it exothermic reaction. So the product is more stable than the reactant. Okay, we call exothermic reaction. In this case, the enthalpy, which is the energy of this reaction, is less than 1. Okay, when it is less than 1, it's spontaneous, and we love that. Okay, give you some example of a spontaneous reaction. Spontaneous means it can happen right away. Okay, the burning carbon, burning charcoal, barbecue. You adding lights, just like maybe like a match, or give it just a little heat to overcome the activation energy, and the reaction just keep going because it's spontaneous. Okay, or the formation of rust. We have iron, we have oxygen. With the sunlight, it's enough for iron and oxygen to overcome the activation energy, and the reactions keep going. It's spontaneous. All right. Now, the other type of reaction. So we have the endothermic reaction. So in this type, it has to be endo, not exo. So endothermic reaction. So in this case, the energy level of the product is higher than the reactant. So the product is less stable than the reactant. All right. When it's less stable, this reaction has to absorb energy from for the reactant to become the product. So it's not spontaneous. Okay. Give you some example right here. So we know that hydrogen peroxide decomposes over time to make hydrogen and oxygen. The backward reverse reaction, no. Hydrogen gas and oxygen gas not going to become hydrogen peroxide. No, needs a lot of energy for this to happen. All right, so the reverse is not spontaneous. All right. Which definition best describe the term activation energy? A, the energy required to remove an electron. No, never talk about it. The energy of motion. What is that? That's kinetic energy. No, ew. Oh no. The energy required to separate ions in crystal. Oh my gosh. Nope. The minimum the minimum net energy that colliding particles must possess in order to react. Yes, that's it. All right. What factors determine whether a collision between two reactant molecules will result in a reaction or lead to the product? A particle must be charged. Never talk about it. No, that's not in a requirement. The particles must collide with enough energy to meet the activation energy of the reaction. Yes, at least the energy has to be at least the activation energy. C, the particles must be in the correct orientation upon impact. Yes, right. Collide at the right angle. Lastly, the energies of the colliding particles must be equal to each other. Nope, they're going to be equal to activation energy. It doesn't have to be equal one another. All right.